You ever wonder about the magic behind things that just, well, keep going? You know, things that loop, repeat, and circle back on themselves without any obvious end? Well, in this explainer, we're going to pull back the curtain on the really elegant data structure that makes it all possible.
I mean, think about it for a second. You're at the end of your favorite playlist, right? And instead of just stopping, that first song seamlessly kicks in again. So how does the computer know to go all the way back to the beginning instead of just, hitting a dead end?
Or, hey, what about a game? Player 1 takes a turn, then player 2, then player 3, and after the very last player goes, whose turn is it? It's player 1's again. Of course. This whole idea of a continuous cycle, it's literally everywhere in the tech we use every day. So the answer to all these questions isn't some super complicated trick. Nope. The answer is actually a pretty clever tool from the world of computer science, and it was designed specifically for these never-ending kinds of situations. The idea behind it is just beautifully simple. And this is it, the circular linked list. The definition from our source material really says it all. Instead of the list having a final stop sign, the very last element is basically given directions to go right back to the start. It creates this perfect, unbroken circle. Now, what's so cool about this slide is how clearly it lays out the difference. A standard or linear list goes from A to B to C, and then it hits null, which is basically a pointer that means end of the road. That's it. But with a circular list, C doesn't point to nothing. It points right back to A, creating that endless loop. So simple, but so powerful. And listen, this isn't just some abstract concept for a computer science exam. This structure is working hard behind the scenes in a ton of applications that you probably use every single day. So let's take a look at where you can actually find it in action. Just look at this list. We've already touched on media players and games, but this structure is also absolutely crucial for managing your computer's memory, for organizing data efficiently in things like caches, and even for how your operating system keeps track of all the space on your hard drive. Every single one of these tasks really benefits from a structure that can just cycle through items without ever having to stop. But, like any tool, it's not perfect for every single job. A circular linked list has a very specific set of strengths and, some weaknesses. Understanding them is really the key to knowing why engineers choose to use it. So on the plus side, going around in a circle is incredibly fast, and any node can act as a starting point. But the disadvantages are super important. Because there's no natural end, it can be a bit trickier to navigate without getting lost. And adding or removing items, that's a little more complex than in a simple linear list. It's a classic engineering trade-off, for sure.
So, here's the crucial point. The greatest strength of a circular list is also its greatest danger, the infinite loop. If you're not careful when you're moving through the list, you can accidentally create a program that just runs forever. That's why programmers have to use these clever little tricks, like keeping a counter or maybe using 2 pointers moving at different speeds, just to be sure they know when they've completed one full circle.
Okay, so we've covered what it is, where it's used, and what you gotta watch out for. Let's boil this all down to the essential takeaways. Here's a super simple checklist for you. First, do you have a problem that naturally repeats or cycles? If the answer is yes, you might need this tool. Second, the way you build it is straightforward. Just connect the end right back to the beginning. And third, and this is the big one, always remember that infinite loop trap. Be really deliberate about how you walk through that list. And this just brilliantly sums up the entire concept. This quote from our source material really gets to the heart of it. Every single item in the list has something that comes after it. There are 0 dead ends, which is precisely what makes this whole structure so unique and so useful. So, I'll leave you with this question to think about. Now that you know the pattern, I bet you'll start seeing it everywhere. Where else in the world of technology, or hey, maybe even in the real world, do you see systems that totally depend on a continuous, never-ending loop?